welcome back to part 2 of looping. And today we're going to be doing a lot of coding. So I suggest you stick around till the end of the video because I can guarantee you learn something new. So let's begin. When we left off in the previous video, we discussed there were three kinds of loops and we discussed one of them in detail, that was the for loop. Today we'll start off with the while loop. So remember in for loop you had three parts while defining the loop, the initialization, the condition and the updation part. Well, we also saw how we could skip either one of those or all of those parts, but that kind of defeats the purpose of for loop, right? Because those are defined to be repeated a specific number of times. So you kind of have to know how many times the loop repeats, how many number of iterations the loop continues for. Well, today we're going to be studying a more dynamic sort of loop, which is the while loop. Now, when I say dynamic, I mean that we do not know the number of times the loop will be repeated beforehand. And it is because all we have in while loop is a condition, as you can see in the syntax right here. There is no updation or no initialization statement written in the header, which is this part, right, which is the part within the parentheses right here. All it has is a condition opposed to what we learned in a for loop. So let us quickly take an example and see how it is different, while how the code structure is different. So if we had to print numbers from 1 to 5, first we had to take a counter similar to what we did in for loop, and then you have while, and the condition is less than equal to 5, and then within curly braces we print our counter. Now note that if I simply run this program, it will be an infinite loop. And what I mean by that is that we are nowhere updating our counter. So our counter will be 1 always, and we'll just get loads and loads of 1 in the output. So we need to update it. So for loop took care of this in the header part of the while loop itself, but since our while loop is only based on a condition, we have to do the updation in the body of the loop. So if we run this, we'll get numbers from 1 to 5, and there we go. So this still so this is how a while loop is written. Now to fully appreciate why we use a while loop is we need to do a problem, and the problem is printing out the Fibonacci sequence. Now all of you who are already familiar with this problem and have do know how to do this in while loop, I suggest you skip ahead because I promise you won't miss anything in terms of new thought, new theory. I'm just showing you how to think. So this is the Fibonacci sequence, dot dot dot. So what is so special about this? How did I came up with this set of magic numbers? Well, if you look closely in a Fibonacci series, every number is the sum of the two numbers before that. So if we pick 5 over here, this is the sum of 2 and 3. If we pick 3 over here, this is the sum of 1 and 2. So how did we get all these? Well, we need a starting point, and the starting points are zeros and 1. So let's write a program for this. Let's think how we can come up with the program for this. So again, we need, so just like we discussed right now, we need two starting terms. So let's define something like first term and second term. Now our first term is equal to 0 always, and our second term is equal to 1. Now I also need to print Fibonacci numbers before a certain limit. So what I mean by that, if the input for my limit is 7 perhaps, so every number in the Fibonacci series before 7 should be printed. So I'll get the Fibonacci series up till here. So it's not 7 numbers, it's rather every number before the number 7. If my limit is 2 perhaps, this will print the Fibonacci series up till here. So now we know what exactly we're working with. So let's declare another variable called limit, and right now just assign it an arbitrary value 10. Okay, so we have a first and second term. How do we decide the next term? So that will be the sum of the first and the second term. So another variable next term is equal to first term plus the second term. We are ready to begin our loop, which will be while some condition and then our loop body within the curly braces. So let's forget about the condition for a moment and let's see what will actually go inside the loop body. So first we just need to print out our next term, which is the sum of the first and the second term, and we've already calculated the next term, so we'll see the answer right there. And what happens next? So if you look closely, we have the first term, the second term, and the next term. So what will happen is that the next term is actually the summation of the first and the second term. So in the next iteration, what will happen is that we discard the first term, our second term becomes the first term, our summation, which is the next term, becomes the second term, and this is actually made by summing up the new first and the second term. So I hope I was clear. Let's translate this into code, which is that a first term becomes the second term. The second term becomes the next term, and the next term is actually the summation of the new first, and the new second term. So once we have that, we need to worry about a condition over here. What should we write down here? Well, if you remember, we had set a limit of 10, right? So this limit is not exactly dependent upon the position of the number in a Fibonacci series. Now, what do I mean by that? Is that the position of the numbers are like this: 1, 2, 3. So zero comes at the first position, 1 is at the second, the third, and so on. So if we do not need the position, we do not need a counter. This limit is actually comparing itself with the numbers. So we check at every iteration, is this summation or the next term less than or equal to limit. So once we do that in the last, so look at 13 over here. So obviously 10 is not less than 13. So here we know that we have to come out of the loop and a Fibonacci series would be up to here, right? So I think we've got a condition if we just keep on comparing limit and next term. So we have to make sure that our next term is always less than or equal to limit. Now if we print that out, let me put a space over here for better readability. So yes, we get numbers from 1 to 8, but hold on. Our Fibonacci series is not just this, it also has these two numbers. So a quick hack to that would be just printing out the first and the second term before we enter the loop itself. But what if our limit was set to 0? If our limit was set to 0, we still want to see this first term over here, right? 0. But we won't be seeing that because the next term is obviously 1 and we are not allowed to enter the loop. So a better way to approach this would be to print out the first term. If we print out the first term, will actually start from 0, and then since our second term becomes our first term, we'll move on to 1 and so on and so forth. But if we do that, we have another problem, is that the next term, so what happens is that the next term is 8 right now. The second, just quickly refer this back. Our next term is 13 right now. Our second term is 8 and our first term is 5. So our next term is already, let me just print these out. Then we'll have a better understanding of what I'm trying to convey. We need the first term, the second term, and the next term. And a new line character over here. So if you look at the output, our first term is now 5, our second term is 18, and our next term is 13. So our next term already makes this condition to be evaluated as false, but that's not exactly what we want, right? We want this to continue up to 8. So and since our first term is the one that's being printed, I think we should change this. I don't think, I know we should change this to first term, because that is the one that is being printed. So that should be the one that is being compared to limit over here. And if we do that, we will get the entire output that we were. Okay, little bit of problem. Just run this again. Okay, so we get our entire Fibonacci series before the limit itself. And now if you see, our first term is the one that exceeded the limit, and the next term is somewhere in 34, but we don't care because we are printing out the first term itself. So this was the example of how we did not know the number of iterations beforehand, right? Because this was a more dynamic, okay, this has gotten a lot messy. So this was all dynamic, right? We did not know how many times we'll have to iterate over the same loop body to till this condition was actually false, right? So this is one way in which while loop is really beneficial. So you can actually refactor the code to actually make this work for loop too, but while loop is more readable in this sense. So now we'll move on to a more interesting but short topic, which are infinite loops. So infinite loops are one that you do not want to run into, right? Because your program just keeps on executing and executing, and there's no end. So but if you for some reason you want to set up an infinite loop, you can do it in two ways. In for, you just have to omit all the conditions defined in the header, which are the initialization, updation, and condition and updation part. So just leave them with blank spaces, and there you go, you have an infinite loop in for while, what happens if this condition inside the header always has to be evaluated to true. So we know that any number except 0 is always evaluated to true. So we simply put a 1 in there for better readability. We do not want any magic numbers in our program except 0 or 1. And there you go, we have an infinite loop in while. Moving on to do while loops. Now, before we begin, if you look closely at this flow chart over here and compare this to the flow chart for while over here, you'll see that the flow chart is just inverted, right? And what I mean by that is that the loop body is executed first, and then we check our condition. And if you look closely at the syntax, you can see how we do that. So first is do, and then the loop body will be executed, and then we have a condition over here. So as opposed to for and while loops, in which the condition is checked first and then it is decided whether we are allowed to enter the loop, the do while loop will execute at least once, because even if this condition becomes false over here, this loop body will be executed at least once. Now, what do I mean by that is that, let me just clear this. Let's set a counter to 0 and let's just print our counter. Now, this should run till this counter is greater than 0. So, the current value of a count does not really satisfy this condition, right? A counter is actually equal to 0 and not greater than 0. But if you look at the output, you'll see that we get 0 right here. So regardless of whether this condition was true or false, this loop executed at least once, and that is why this is known as exit control loop, because the condition is actually towards the exit and not the entry point of the loop. Now, where possibly could we use this kind of loop? Because the creator of C++, Bjarne Stroustrup, said that he avoids using this because the same thing can be done with the help of a while loop. Well, yes, you won't need to while loop like 99% of the times, but the reason is that the reason of using do while loop is actually to improve readability. Now, what I mean by that is, let's take a small example where we need to keep on accepting input from the user until a negative number is entered. So all we want is positive numbers. So I already have a program for that. I'm going to copy that right here, and let's just walk through it. Okay, so what's happening is that we have a positive number, and I've taken float so that we can have both decimal and integer values. So we are asking the user, and let's just see this in practice. So we are asking the user to enter a number, and we can go with float or anything else, but as soon as this number turns negative, so let's enter -5, we come out of this loop. And I know we can reformat it to do the exact same thing with while loop, but this just feels more human like, it feels more readable, like we have to do a certain task till a certain condition is true. Okay, so this is some, I guess, I need for a do while loop. And moving on, we come to nested loop. So what is a nested loop? Well, it's a loop within a loop. Simple, plain and simple. But what does this exactly do is that till now we could either print something out in the horizontal direction for the output, or we could print something out in the vertical direction using an endline character, right? But what if we could control the output in both directions? So we could print in the horizontal direction as well as the vertical direction. So for that we need a nested loop. So one part of the loop will take care of this horizontal part, and the next part of the loop will take care of jumping to another line to print out this horizontal part. So this actually is somewhat similar to a matrix in maths, but if you don't know what that is, it's simply a representation in terms of rows and columns. So if you look closely, these are actually columns, right? This right here, and these are actually rows right here. So we could our output could actually look something like this. And how do we do that? Well, I'm going to write the code first, and then we are going to go over this step by step. So first we need two variables for number of rows, sorry, for two loop variables for rows and columns. And then we need another which will specify the total number of rows and the total number of columns. So right here, the total number of rows is 3 and the total number of columns is 4, right? So let's just store this in some variable called num rows and num columns, 3 and 4 respectively. Okay. Next, we have something called an outer loop. So our outer loop is what controls the rows. Our outer loop is responsible for taking us from from row to row. So changing lines basically. And how do we go about that? Is that we have row is equal to 1, and then row should be less than equal to num rows, and then row plus plus, and then we have another loop inside that where column is equal to 1, column is less than equal to number of columns, and again column plus plus. Now let's just print anything right here. I'll just go ahead with an asterisk. That's it. And if we are getting some sort of problem right here. Why are we getting that? Well, oh yes, we forgot about the semicolon and put a comma instead. So yes, that. And if we print the output for this, we get everything in a single row. Now you were promised this, but instead you got this. What happened is that the print statement did not shift its control to a next line. So after we print out all the columns right here, we need to go to the next line, right? So we'll just print a new line character over here. And I believe we should get that. Oh, yes, we got this. Okay. Now what's going on? So let me just copy this quickly over to the whiteboard here. Okay, so we started out with our row is equal to 1, right? So right now we are, shouldn't have deleted that part. Okay, I'll just make a small grid over here. Right now we are here in our output, okay? And so the row is 1, and then we move on to this inner nested loop, and a column is also 1. So right now we are at row 1 column 1, right? And then we print a star, so a star is printed over here. But then we do not move on to this, because our inner loop has to be executed till completion, right? So what we do is, okay, I need to expand this a bit. Column plus plus is not visible. Yes, now it is visible. Okay, so once we have that, next we have to update our column, because our column loop is still not complete. So our column becomes 2 now, and our row still remains 1. So right now we are at row 1 column 2, and then we have a star to print, and this goes on till we reach column 4, right? And then a column becomes 5, and this condition is evaluated as false, and we go down and a print statement is executed, and from here we jump to here to a second row. So right now we are at row 2, right? Because our row was 1 and then it became 2, and then again we have to execute this entire inner loop. So this will repeat row 2 column 1 2 2 until to 4, and we'll get asterisk 4 times, and then again we have a print statement at the end of the inner loop, and we'll jump to our column 3, and now our row becomes 3, and then the entire thing will repeat itself. So this is how we got this output right over here. And if you actually go on to print the row and the column, you'll get a better understanding of what's going on behind the scenes. So we just print row column with a space, row column with a comma, and then we'll give a space over here. Let's see what we are getting. So like we mentioned, so first row, first column, and then this continues and moves on. So this is really interesting because we can use this to generate all sorts of patterns, and we are going to be discussing exactly that in our next section, which is nested loop tricks. Now, what if I wanted to print something like this? This is a left aligned triangle, right? So we know that something like the row is keeps on changing, but the number of columns is not remaining constant. Now, if we draw this on the whiteboard over here, if you notice closely, our number of columns depends on the number of rows, right? So this is row number 1, so we have only one column. This is row number 2, so we have two columns. This is row number 3, so we have three columns. So how do we do that? Is that let's get rid of this number columns because this depends on the number of rows. Let's keep the number of columns equal to 3, and this entire thing will remain the same because we actually need 3 columns, right? But since our column depends on the number of rows, we'll print out row right here. So this makes it dependent, and if we so we wanted that 1 2 3 pattern, right? So let me just quickly print column over here, and we'll see the output, and then we'll go over this step by step. So yes, we got this output. So what's happening is that we we are in row 1 column 1, right? And then we are checking if this column is less than equal to row, which is 1 right now. So once we printed out this 1 right here, then our column becomes 2, but no, now it has exceeded our row. So 1 is not less than or sorry 2 is not less than or equal to 1. So our inner loop has actually completed executing, and then we move on to a second iteration of the outer loop, which is now row is equal to 2, and then we have this condition that column should be less than or equal to 2. So beginning from 1, a column will actually be executed 2 times, and then in the third row this will be executed 3 times. So I hope you get what this is, and if we want something like this, if we want something like this, which is an inverted left aligned triangle, then what will we do? Well, let me just write this out over here. Okay. So right now we have 3 to 1, and let's not mention character numbers, rather let's play with asterisk. Okay, So again, the number of columns is dependent on the number of rows. But rather than this being row number 1 and the number of columns are 3, but then in row number 2 the number of columns are 2, but in row number 3 the number of columns are 1. So we can infer that the number of rows are increasing, but the number of columns are decreasing. But why do we go ahead and change that? It's a free country. We can visualize this as 3, 2, 1. The meaning still remains the same, and now it's easier, right? Because with row number 3 you get 3 columns, with 2 and so on. So, and it's more easier to convert this into code. So we had a previous pattern, right? And now, just like we discussed, our number of rows begin at num rows, and then we have to decrease this value. So we are putting minus minus, and then till when we have to decrease is that row should be greater than or equal to 1, right? And then if you look closely, our number of columns depends upon this row. So our column has to be initialized with the new value of row every time, right? And then the condition remains the same, that this loop should be executed till column is greater than or equal to 1. And since we are decreasing our number of columns with every row, then minus minus of column. And if we run that, you'll see that we get an inverted triangle, right line, sorry, inverted left aligned triangle. So that's it. Let's dive into a more interesting type of pattern, which is the right aligned triangle. So you notice that it's similar to the left aligned. There's only spaces here. So if I draw this out, one, it is 1 2, and then it's 1 2, sorry, 1 2 3. So you can notice there are two spaces in the first row, 1, and there are no spaces in the last row. So as we keep on increasing the number of the number of rows, the number of spaces in front should keep on decreasing. So how do we go on to achieve it? Well, first let's change our code back to the way it was, to print a left aligned triangle. Okay, I'll have to just write it again. The row should be less than equal to num rows. And column is equal to 1. Let's see if we are getting our left aligned triangle. We are. So at the beginning of every inner loop, this loop for columns, we should have a specific amount of spaces. So remember the inverted triangle that we just, so this is sort of an inverted triangle, and you can write a code to print this inverted triangle, and then you could just print a left aligned triangle as well. But we're going to do things a little more differently. You see, printf has this unique property in which you can determine if you can specify the width of a certain character. So right now a width is actually dependent upon the number of rows minus row. So our number of, so first we have a number of rows equal to 3, and then minus row is equal to 1, so we have 2 spaces. Second, it's 3 minus 2, so 1 space, and then it's 3 minus 3, so no space. So if we just go ahead and write this row, and this is the width, right? And then the character that we want to print will be a space. Okay, so we have that, but if you remember, The modulo C is used to print just a single character. So how are we printing essentially a number of characters with just a modulo C? Well, we are not. We need something else, which is an asterisk before the modulo and after the modulo and before the C. An asterisk is basically a pointer, and we'll learn more about this in the later videos. But just remember this cool little syntax trick for now, is that an asterisk C helps you print out a string of characters. Okay, so if we do that and we run our program again, well, you see that the first two are actually aligned, but the second still has a space in front of it. Well, this happens because there's a printf statement, so something is going to get printed even if this width or the number is 0. So to combat that, let's just put an if statement. So if the num rows minus row, and need to check if this is equal to 0, because any number except 0 will get evaluated as true. So this will run for any number. All you need, and as soon as this turns 0 in the last iteration, this will not be evaluated. So all we need to write is if num rows minus rows, and this will be evaluated as 0. And if we go run this again, we will have a perfectly inclined right aligned triangle. So I hope this was fun, and we can add many other sorts of patterns can be made, a pyramid, an inverted right aligned triangle. Just go and try this out, and you will run into infinite loops while trying out patterns, but don't worry, just give it a go, experiment, and you'll have fun. And once again, we have put up a few very interesting problems on HackerRank and a few basic ones so that you can just keep on practicing, and go ahead and try that. Good luck and thank you.